When copper water lines enter a house and transition to plastic, the question arises whether a short section of copper pipe connected to a tub needs to be bonded. The answer is no. Bonding is generally required for metal piping systems that are likely to become energized and could pose a shock hazard. When the majority of the water piping system is plastic, the short copper stub connected to the tub is not considered likely to become energized. Therefore, bonding is typically not required. This principle is based on the understanding that plastic piping does not conduct electricity. Consequently, it isolates the small copper section from the main electrical system of the house. Electrical codes, such as the National Electrical Code, or NEC, provide specific guidelines on bonding metal water piping systems. These guidelines aim to minimize the risk of electrical shock by creating a low impedance path for fault current to return to the source. This ensures that overcurrent protection devices, like circuit breakers, trip quickly, de-energizing the circuit. In situations where the water piping system is predominantly plastic, the small copper section at the tub does not present the same risk as a continuous metal piping system. The NEC addresses bonding requirements in Article 250. First, Section 250.104 covers bonding of metal water piping. It states that metal water piping systems that are likely to become energized shall be bonded to one of the following: firstly, the service equipment enclosure; secondly, the grounded conductor, the service; or thirdly, the grounding electrode conductor if of sufficient size. The purpose of this bonding is to create an effective ground fault current path. Secondly, Section 250.104 also includes an exception. It states that it is not required to bond an isolated section of metal water piping that is not likely to become energized. In the scenario described, the plastic water lines isolate the small copper section at the tub. Therefore, it falls under this exception. Thirdly, understanding the intent behind bonding requirements is crucial. Bonding aims to reduce the potential for voltage differences between metal parts in a building. These voltage differences can occur due to various factors such as faulty wiring, lightning strikes, or induced currents. By bonding metal parts together, the voltage differences are minimized, reducing the risk of electric shock. Fourthly, when plastic piping is used extensively, it interrupts the electrical continuity of the water piping system. This interruption reduces the likelihood of the copper section at the tip becoming energized. As a result, bonding becomes unnecessary. Fifthly, local electrical codes may have specific requirements that differ from the NEC. It is always essential to consult with a qualified electrician or local building inspector to ensure compliance with all applicable codes and regulations. Sixthly, consider a scenario where a metal water pipe is unintentionally energized due to a wiring fault. If the piping is properly bonded, the fault current will flow back to the source through the bonding conductor, tripping the circuit breaker. This quick disconnection of the power supply prevents a danger shock hazard. Seventhly, in contrast, if the piping is not bonded, the fault current may not have a low impedance path to return to the source. This can result in the metal pipe remaining energized at a dangerous voltage level, posing a shock hazard to anyone who comes into contact with it. Eighthly, the size of the bonding conductor is also important. The NEC specifies the minimum size of the bonding conductor based on the size of the service entrance conductors. The bonding conductor must be large enough to safely carry the fault current without overheating or melting. Ninthly, the bonding connection must be made securely and reliably. The connection should be made using approved connectors and methods to ensure a low impedance path. Corrosion or loose connections can increase the impedance of the bonding path, reducing its effectiveness. Tenthly, it's also important to note that bonding is different from grounding. Grounding refers to connecting electrical equipment to the earth. Bonding refers to connecting different metal parts together to equalize their voltage potential. While grounding is essential for safety, it is not always required for metal water piping systems. 11thly, when retrofitting a plumbing system with plastic pipes, it is crucial to assess the bonding requirements. If the original system had continuous metal piping, it may have been bonded. In this case, it is essential to ensure that the remaining metal sections are properly bonded or that the bonding is no longer required due to the extensive use of plastic piping. 12thly, consider the situation where a metal tub is connected to a plastic drain pipe. In this case, the tub itself may not need to be bonded if it is not in direct contact with any metal water piping. However, it is still essential to ensure that the electrical system in the bathroom is properly grounded to protect against shock hazards. 13thly, when installing new plumbing systems, it is always best practice to follow the recommendations of a qualified plumber and electrician. They can assess the specific circumstances and ensure that the system is installed in compliance with all applicable codes and regulations. 14thly, remember that the primary goal of bonding and grounding is to protect people from electric shock. By following the guidelines in the NEC and consulting with qualified professionals, you can ensure that your electrical and plumbing systems are safe and reliable. 15thly, in summary, when copper water lines transition to plastic before reaching a tub, the short copper stub connected to the tub typically does not need to be bonded. This is because the plastic piping isolates the copper section, reducing the likelihood of it becoming energized. However, it is always essential to consult with a qualified electrician or local building inspector to ensure compliance with all applicable codes and regulations. 16thly, the NEC provides specific guidelines for bonding metal water piping systems, but also includes exceptions for isolated sections that are not likely to become energized. 17thly, understanding the intent behind bonding requirements, which is to minimize voltage differences and provide a low impedance path for fault current, is crucial for ensuring electrical safety. 18thly, plastic piping interrupts the electrical continuity of the water piping system, reducing the need for bonding small copper sections. 19thly, local codes may vary, so always verify compliance with local regulations. 20thly, proper bonding helps to trip circuit breakers quickly in the event of a fault, preventing shock hazards. 21st, unbonded metal pipes can remain energized at dangerous voltage levels, posing a significant risk. 22nd, the size and quality of the bonding conductor and connections are critical for ensuring effective bonding. 23rd, bonding equalizes voltage potential, while grounding connects equipment to the earth. 24th, retrofitting plumbing systems with plastic pipes requires reassessment of bonding needs. 25th, even with plastic drain pipes, electrical grounding in bathrooms remains essential for safety. 26. Always consult professionals for plumbing and electrical installations to ensure code compliance. 27th, the ultimate goal is to protect against electric shock through proper bonding and grounding practices. 28th, consider different types of plastic pipes and how they affect bonding requirements. For example, PEX or cross-linked polyethylene is a common type of plastic pipe used in plumbing systems. It is non-conductive and effectively isolates metal sections of the piping system. 29th, PVC or polyvinyl chloride is another type of plastic pipe commonly used for drain, waste and vent or DWV systems. Like PEX, it is non-conductive and does not require bonding. 30th, CPVC or chlorinated polyvinyl chloride is similar to PVC but can withstand higher temperatures. It is often used for hot water distribution systems and is also non-conductive. 31st, the type of fittings used can also affect bonding requirements. If metal fittings are used to connect plastic pipes, the fittings themselves may need to be bonded if they are exposed and likely to become energized. 32nd, consider the proximity of other electrical equipment to the water pipes. If the water pipes are located near electrical panels, outlets, or other electrical devices, the risk of them becoming energized increases. In such cases, bonding may be necessary even if the pipes are mostly plastic. 33rd, think about the potential for corrosion. Over time, corrosion can degrade the metal parts of the plumbing system, increasing the resistance of the bonding path. Regular inspections and maintenance can help to identify and address corrosion issues before they become a safety hazard. 34th, also evaluate the overall electrical system in the building. If the electrical system is old or poorly maintained, the risk of electrical faults increases. In such cases, it is even more important to ensure that the plumbing system is properly bonded and grounded. 35th, bear in mind the effect of stray current. Stray current can flow through the ground and other conductive paths, potentially energizing metal water pipes. Proper bonding and grounding can help to minimize the effects of stray current. 36th, one should not neglect the role of ground fault circuit interrupters, or GFCIs. GFCIs are designed to detect small amounts of current leakage to ground and quickly disconnect the power supply. They are commonly required in bathrooms, kitchens, and other areas where water is present. 37th, GFCIs can provide an additional layer of protection against electric shock, even if the plumbing system is not perfectly bonded. 38th, the NEC provides specific requirements for GFCIs in Article 210.8. These requirements specify where GFCIs are required and the types of circuits that must be protected. 39th, arc fault circuit interrupters, RFCIs, are another type of circuit breaker that provides protection against electrical fires. RFCIs are designed to detect arc faults, which are dangerous electrical discharges that can occur in damaged or worn wiring. 40th, RFCIs are often required in bedrooms and other areas where people sleep. They can help to prevent electrical fires by quickly disconnecting the power supply when an arc fault is detected. 41st, the NEC provides specific requirements for RFCIs in Article 210.12. These requirements specify where RFCIs are required and the types of circuits that must be protected. 42nd, it is also important to consider the potential for lightning strikes. Lightning strikes can induce high voltages in metal water pipes, even if they are mostly plastic. Proper grounding and surge protection can help to minimize the effects of lightning strikes. 43rd, surge protective devices, or SPDs, are designed to protect electrical equipment from voltage surges caused by lightning strikes or other electrical disturbances. SPD are typically installed at the service entrance and can help to prevent damage to sensitive electronic equipment. 44th, the NEC provides specific requirements for SPD in Article 285. These requirements specify where SPD are required and the types of equipment that must be protected. 45th, remember that electrical safety is an ongoing process. Regular inspections and maintenance are essential for ensuring that your electrical system is safe and reliable. 46. If you have any concerns about the safety of your electrical system, it is always best to consult with a qualified electrician. 47th, electricians have the knowledge and experience to identify and address potential electrical hazards. 48th, they can also help you to ensure that your electrical system is in compliance with all applicable codes and regulations. 49th, by following these guidelines and working with qualified professionals, you can create a safe and reliable electrical and plumbing system for your home. 50th, in conclusion, while bonding might seem complex, understanding the basics ensures safety and compliance with electrical codes. Always prioritize safety and seek expert advice when in doubt.